Welcome back to my workshop. Now, about a month ago, I was in the middle of a project, this one, and I was making a motorcycle stand. Now, for those of you that follow me on Instagram, you would have seen what happened. Yes, it went horribly wrong. Now, the reason it went wrong was because my CNC spindle decided to die. This is what happened. Well, I'm only halfway through the project and my CNC spindle is dying. Listen to this. Okay, so the CNC spindle I currently have is this little fella. Okay, it's a 500 watt air-cooled brushless DC motor type. It comes with the spindle and also a control power supply. Now this has obviously gone horribly wrong, so I've decided to replace it with the new unit. So I've got them in the box now. They've arrived from Amazon. Let me show you what they are. Okay, so my order's arrived. I've got 3 boxes here. One of them is a VFD, which I'll explain in a minute. The other one is the spindle, and the other one is a bracket to hold it to the CNC machine. So let's get these out of the box and we'll have a closer look. Okay, so first off, we'll open this, which I've already opened. Now this is a VFD, which is a variable frequency drive. This comes with a little box, which is basically the control and book of words. Okay, we'll have a look at those in a moment. Put that out of the way. Now this should be the spindle. Okay, what do we get in the box? We get another book of words, which is mainly in Chinese. We get 2 spanners. Put it in the box. 2 spanners. Then this should be the spindle. Ooh, spindle. Okay. As you can see, it's much bigger than the old one. I'll compare them in a minute. Okay, so that's the VFD and the spindle. And a bracket. Okay, that's quite a size. Right, let's quickly run through how much these things cost. Okay, so my favourite shopping place is in Amazon. I managed to get this as a package. It was the spindle and the VFD. As you can see, it's a 1.5 kilowatt air-cooled spindle, not a water-cooled spindle, with an ER11 chuck. Okay, and that was £176.38. You can see the VFD there. It's a cheap copy of a Chinese copy, but it seems to be working okay. And there's obviously the spindle, and yes, it's nice and shiny. Okay, just another quick look there at the dimensions. So if you go on Amazon and just put in 1.5 kilowatt CNC spindle, and the bracket I got was this one. It looked much better quality than some of the other ones. It was the right size and it was £23.18. Made sure I got the 65mm bracket. I've got to modify this to actually fit it to the CNC machine. So that's what I bought. Okay, so first off, let's have a quick look at the spindle. This is what you get. You get 2 spanners, which are covered in sellotape. They're not the best quality spanners in the world, but they might be sufficient. I'll probably use my existing spanners, but it's nice to know you got them. Once you can get the sellotape off, it should be all right. You get a book of words, which a lot of it is obviously in Chinese. Then it's on English on the back, which is open to interpretation. Okay, but I will read through that. Okay, in the box you get the spindle, you get 2 collets, and you get an electrical connector. Okay, it smells very chemical. I think it's coated in oil. Right, so this is the new spindle. Comparing it to the size of the old one, it's massive. okay, and it weighs quite a bit, but hopefully the CNC machine will be able to cope with it. It comes with an ER11 size collet. Okay, we've got 2 extra collets here, so in theory I should be able to use my existing bits. Right, so what we've got is a 220 volt, 1.5 kilowatt, 400 hertz, 24,000 RPM spindle. Okay, the 400 hertz will become apparent later. Okay, and that's what you get. The electrical connector, I'll quickly go through wiring this. This obviously fits on here. Okay, so let's have a look at the VFD. Okay, so a VFD, it's a variable frequency drive. Now this is needed because effectively my old spindle was a DC motor, but this one is effectively an AC motor. So what this does is it provides variable frequency to the motor to spin at different speeds. Okay, what you have to do is wire this into the mains and then wire from here to the spindle. Then you control it on this control panel. The control panel can be removed, and if you want to, you can extend it so you can have this mounted somewhere else, but you need a ribbon cable, which I don't have, so I will probably use it like this. The electrical connections go in here. Okay, this is where your main power goes and then your supply to the spindle. All this side here is a control side, so if you want to control it with the likes of Mac-free software, you can control obviously turning it on and off and controlling spindle speed. You can also put an extra pot in here. Now on some of these VFDs you see there's a pot here, a little twiddly knob, which you can actually use to adjust the frequency and the speed. Okay, but this one is a cheap version and it hasn't got the pot here, but you can add an additional pot here if you want to. I shall get it running and then use these controls for now to actually increase and decrease the speed. Obviously you've got run, stop, set, forward and reverse, 2 jogs and an up and down, and we'll quickly go over that later. Once you've wired it in, it's not a simple case of just turning it on and going for it. You have to actually program this, and then I'm hoping there's sufficient detail in here to help me do that. Okay, there's a little wiring diagram. This is obviously relevant to me because it's going to be a single phase. Okay, and then it should tell me all of the programming parameters that I have to follow. Okay, so first thing to do will be to get some power to this. Right, here we go. Okay, before we wire in the VFD, a quick look at the bracket. Now obviously this is, compared to the old one, this is absolutely huge. Basically the spindle will sit in this bracket. It's very tight, so there might be some manipulation to get it actually fitting, but it's supposed to be 65mm. Okay, be very careful when you order these. There's various different levels of quality. This one doesn't seem too bad, but some of the other ones I've seen have got a lot of swarf where they've not been finished properly. This one seems okay. Obviously I've got to drill some holes to actually mount it, but that's a thing in itself. It's massive. Okay, and then that should fit in there, but it's a bit tight. Okay, onto the VFD. Okay, so to wire in the VFD main power supply, obviously we need a plug on a wire. Now remember, if you're not confident with doing electrical, or if you're not competent of doing electrical work, please don't do it. Get someone else to do it that knows what they're doing. Obviously this is going to be mains power, and this is going to hurt, if not potentially do you some nasty damage. Okay, so the type of connectors we got here are screw type connectors that you actually undo the screw. Okay, you undo the screw and it lifts up this little plate, and then the wire goes in there, and then you tighten the screw down. Now I've seen some people just screw the wire directly in, obviously like this with a bare wire. I don't recommend that at all. What I recommend is doing at least bare minimum this. Okay, so there's basically a small fork terminal like this. Okay, and then what I've done is I've actually soldered it as well. These are a crimper type, but I've actually soldered it as well. Okay, so quickly to show you how to do that, first thing you need is some heat shrink. That's this black stuff here. Okay, you buy that in tubes. Now I bought this one from Powerfix, so that's from Lidl's. You know, this whole box probably cost me £3. All various different sizes of shrink wrap. Okay, or heat shrink should I say. Okay, so the first thing you do is you put a heat shrink sleeve over. Okay, then what I've done to be on the safe side is I've actually soldered this, so I basically tinned this end. Let me quickly do that. Okay, so basically now what I've got here is the wire, and it's coated in, I basically tinned it with solder. Okay, I'm going to trim the end off to make it nice and tidy. Okay, then with your little fork terminal, show you that, it's one of these, wire goes in here. Okay, I put that on, and then this, because this is a crimp type, you basically get your really cheap and nasty crimping tool. Okay, and crimp, crimp, crimp. Okay, make sure that is proper secure. Okay, and then what I do is I will also solder this, so to make sure there's a proper electrical connection between the wire and the fork or the terminal. Okay, now. This is probably the worst soldering ever because I'm reaching over the camera. Okay, so I've now got that soldered as well. Now let that cool down before you move the shrink wrap up. Otherwise what happens is the shrink wrap, like it's done here, the shrink wrap gets warm and it grips onto the wire. So what I have to do now is trim this back before I move it onto the terminal. Okay, let me just let that cool down. Okay, so I've now let that cool down a little bit. I've had to trim this back because the heat shrink shrank. The heat shrink shrank. Okay, then all you do is you move the heat shrink over the majority of the terminal, making sure you don't get any heat shrink across the electrical terminal, okay, where it contacts. Okay, so it's like this. And you get yourself a little heat source. You can either use a hot air gun or you can use a little blowtorch like this. Okay, and then you basically gently heat it and it shrinks into place. Okay, turn that off before you burn yourself. So then what you have is this. Okay, so this is insulated, secure, and it's ready. Okay, just got to do the ground and then we'll be ready to connect it. Okay, so these terminals are all ready now. To connect it to the VFD, you can see here it's got R, S and T. If you refer to the manual or the wiring diagram, okay, it shows you R and T, which is the live and neutral, and obviously you've got the ground as well, or the earth. Okay, so the live is R. Okay, R, I put the live to the R. Neutral is T, so same again, we loosen off the screw which raises the metal plate, connect our terminal and then tighten it securely. Don't over tighten it because you'll break it. Okay, and then obviously the earth, same thing. Okay, so that's those three all secure. Now there's no stress relief on these, so we'll have to do something. On some of the other VFDs, this actually goes through a membrane and it actually holds it tight. But there's nothing to do that on here, so I'll have to find some way of securing it to stop them being pulled out. Okay, that's the power side. Now obviously the motor side is a different story. Let's get to that now. Okay, so for the actual spindle, you get this connector, okay, which looks like quite a chunky connector. Basically what you have to do is remove the strain relief, and then this end unscrews, okay, and then you can see the connecting terminals. Okay, now there's 4 there. One of them should be a ground or an earth, but it's not actually connected. Now it specifies in the book here that it's not connected. So I'm going to follow the rules and I'm not going to connect it for now and see if it has any adverse effects. Okay, but that's that end, that's the spindle end. But first of all, we need to connect to the VFD. Now the cable you need is this type of cable. Okay, let's try and get this in focus. Okay, so it's 4-core shielded. Okay, this has got a braided shield on it. Don't cheap out on this. Okay, you must get shielded cable. If you don't, you're going to end up with all sorts of trouble. Okay, so at bare minimum, you've got to get 4-core braided cable. Now what you do on the spindle end is these 3 of them connect to the motor, and then the next one is your braiding. Okay, you open up the cable and pull the braiding over, and then you terminate this the same as you do the others, and you ground that. Okay, then that shields, that makes the most of the shield. All right, don't scrimp out on that. You must get this. All right, it's quite expensive, but you can get it from the likes of RS Components. Right, so for the VFD end, same again, we'll open this, we'll terminate it the same way as we do with the power supply. Okay, so now at the VFD end, I've got my 3 main wires connected and my shielding wire connected. Okay, and on the other end, I've bared the wires back, ready to solder into the plug. Now, back of the plug, okay, the numbers are not very clear at all, but you can see they're numbered 1, 2, 3, and 4. Now 4, I've put a little black mark on it. Okay, and the reason for that is on the very clear instructions, it says number 4 ground wire or not connected. Now this is very poor translation. It's better than my Chinese, but looking at this, you just connect the 3 wires and then do not connect the ground. Okay, that's what the words say. So what I've got to do now is obviously connect these 3 wires, okay, not the ground, to this, and basically I'm going to solder it straight into there. Okay, let me get on with that. Okay, so now on the spindle end, I have the 3 wires connected. Pin 4 is still left unsoldered. Okay, now I've got to put this connector back together and it should be ready to go. Okay, so it's now connected at the VFD. It's now connected at the spindle. Okay, we've got a bit more insulation at this end as well now. Now, before we go any further, remember we still haven't powered this up. What would be a good idea would be to do a continuity check between each wire, each of the 3 main wires on here, and the body of the spindle. Okay, we don't want any electrical connection between any of those and the body of the spindle. If we do, then when you power it up, it's going to go bang, or you're going to get electric shock. Okay, if you don't know how to do a continuity check, then you probably shouldn't be doing this in the first place. Okay, but basically we're looking for an open circuit between each of these terminals and the body and the connector of the spindle. Okay, it's all good. And then checking across each wire, checking the continuity, you should have the same resistance. Okay, don't just use your buzzer, use resistance. Okay, also check between your shield wire and this shouldn't be connected. Okay, right, once you're happy with that, then what you must do is disconnect the spindle. Okay, for the next step, we don't want the spindle connected. Okay, so unscrew that and that should pull off. Okay, put that to one side. Right, let's power it up. Okay, so that's all the wiring done. I've left it overnight, I've come back to it the next day. Right, shall we power this thing up? I've disconnected the spindle, so I now have just got the power supply to the VFD and the spindle's disconnected. Let's power it up and then start going through the programming, which is detailed in the instruction book. Right, first of all, let's power it up and see if I let any smoke out. Okay, so I've got it plugged in. I've actually got it plugged in through one of these, which is just because I haven't got an on-off switch on my power. Right, okay, let's power it up. This is either going to go very well and nothing's going to happen, or it's going to go terribly wrong. Right, 3, 2, 1. Okay, fan started. Yeah, okay, see if we can get some closer looks. Okay. Right, so what we've got to do now is program it. Okay, so what we need to do is look in the book here, and each of these PN numbers here, so for example PN01 is, it tells you a description of what the program is, and then it gives you a value, and it also gives you a default value. Okay, on the next page in this one, it actually goes through in more detail. Okay, the main things we're interested in at the moment is the frequency of the spindle. I think looking through these, most of these are default, so I should be able to just use it. But what I'll do is I'll quickly run through this to make sure it's set as a 400 Hertz spindle, make sure the ramp up time and ramp down times are okay. So I'll basically go through that. Now to program it, all you do is, if you can see this, you push the set button, then that brings up the PN number, then you increase or decrease the PN number here, okay, until you get to the one you want. So that's 2, so we go to PN2. So PN2 is the startup frequency. It defaults to 400. Okay, so I think I'll leave it at that, but just to show you what it is. Okay, so you do set, PN2 set, and it says 400. Okay, so I'm good with that. And if you push set again, it moves on to the next PN number. Okay, that seems fairly straightforward. The instructions don't really show that very well. So I'm going to go through all of these. I won't do it on camera. I'll go through all of these to make sure that they're set to acceptable values. And then hopefully I'll be able to connect my spindle. Okay, so now I've gone through all of the settings in the book here. They all seem to be set at the default values, which all suit this spindle. Now before I connect the spindle, obviously I want to turn this off. Now don't just turn it off and straight away start doing things. You have to wait, because there's capacitors in here. You have to wait for them to discharge. So turn it off. Okay, it looks like it's still alive. The capacitors inside are actually discharging at the moment, and then it will give you a message. Okay, and then this should go off. Hopefully, yep, that's off. Okay, so we can now assume that this is discharged. Okay, so now I can connect my spindle and then power this up again. Okay, so now the spindle is connected. Don't force this connector because it is possible to actually screw it in the wrong way. There's a locating pin which will let you know that it's in the right way. Okay, so this is now plugged in. I've got my spindle laying on the package it come in just so it's stable. Don't leave it just rolling about on your bench because it will go all over the place. What we have to do is check to make sure that this collet is tight using the top quality spanners that we got with it. So we'll make sure that that's tight before we start. Otherwise it could spin off, which would be no good. Okay, probably would have been easier to remove that. Okay, so now we're ready to power up. Okay, so remembering all of the controls are going to be done on this panel. There isn't any potentiometer here, little twiddly knob, there's none of that there. You can fit one inside, but then it means you've got to change some of the parameters here and have the right value per potentiometer. For now, I'm going to use it on the panel here. Okay, I'll put a little bit of tape on here just so you can see when it's going round. Okay, right, let's turn the power on. Okay, nothing strange happening now. So the run and the stop button, okay, is what you will use for this. Now be prepared to stop it. Okay, so run, so it's spinning, and it's actually showing the RPM on the gauge here. Okay. Okay, so I've taken it down a little bit, don't want to run it too fast. Okay, back up again. So quiet, it's ridiculous. Looks like you've got a very good level of control here. Okay, and stop. I like that. It's so quiet. Right, I'd call that a success. Okay, there's one little thing I'd like to mention at this point. After you've got it going and you've had it spinning round, if you check on the control panel here, there's a forward and reverse light. Okay, make sure that when it's going forwards, it's going in the same direction that's shown on your spindle. Yeah, okay, it's got an arrow on your spindle. Most of them will probably have this. Okay, so that is forwards. If it's going the wrong way, even though there's a forward and reverse button on here, okay, really that's not right. Okay, so if it's going backwards, basically, the simple solution is this U and W wires here. Yeah, just swap those around. Okay, and all you'll do is you'll reverse 2 of the phases on the motor and it will spin the other way. Then this will be correct. Okay, forward and reverse on here will be correct. Okay, that's just a little tip. Right, I'm so impressed with how quiet this is. I thought I'd quickly compare it to a normal trim router. Now, some people use trim routers in their CNC machines, and I think it's quite loud. Now, obviously, if you've got a machine running for hours on end, noise becomes an issue. So I'm going to do a quick experiment here. I'm going to run this and then I'm going to run this. Okay, and we'll see the difference in noise. Okay, the microphone is here, so it's right in front of it. So first off, I think you get more noise out of the fan from the VFD. So let me start this up first. Very quiet. I can hear myself talking. Okay, obviously it ramps up, does get a little bit louder, but you can still hear me talking. Okay, I won't move the microphone. This is the same distance away from the microphone. Let's just listen to what this is like. So, quiet, not so quiet. Okay, so now we know the spindles are working fine. We have to mount it. I won't go into all the mounting process now, but this is my new bracket. Okay, just to give you an idea, this is the bracket of my old spindle. This is massive. This is tiny. Okay, now if we look at this one, okay, it's obviously exactly the right size for the spindle, but it's very exactly the right size. In fact, you can't just drop the spindle in because it just won't go. Now you would think, oh, I know, let's lever in here to get this apart. We don't need to. Okay, that won't fit in there just by pushing it in. What you have to do is on your bracket here, this has got 3 holes and the middle one is threaded. So what you do is you take one of the bolts out, you put it in the middle one, the thread is in this section. Okay, take it down until it contacts this bit, tighten it up a little bit more and it effectively opens it up. Okay, don't go too far because you might break it. Okay, so now the spindle slots in. Okay, and then obviously if you loosen this, it grips the spindle again. Take that out of the middle, put it in this end. Okay, haven't even tightened these two up, and now you can see that's already solid. Okay, that's just a tip on actually fitting this bracket. Right, I think that'll do. Okay, so I think that's about it. That's basically my new 1.5 kilowatt spindle for my CNC machine, being driven by a VFD. Hopefully that's covered the basic wiring and basic setup of the spindle to get it going. Now be very careful if you're doing any wiring. Don't do it if you're not 100% sure of what you're doing. Be very careful because you are talking about mains voltage and it hurts and it could do some damage. All right, if you've got any doubts, then get a qualified electrician to do it. What I've got to do now is obviously get this drilled out so I can mount it straight onto my CNC machine, and I'm sure you'll see it in action in some later videos. Right, thank you very much for watching, and I hope this was of some use. Okay, so for now, bye.